Hey, this is Mr. Elmhorst. This is with a science lesson on aqueous solutions. So this is the intro where we're going to start talking about solutes and solvents. And if we mix them together, then we get a solution. All right, so there's writing question number 1 on your printed sheet. The substance being dissolved in a solution, okay, the solute is what's going to go into the solvent to make the solution. So number 1, write down solute. Okay, the substance in which a solute is dissolved into. So the solute goes into the solvent, and that makes the solution. So number 2, go ahead and write down solvent. Okay, a solution is going to be a homogeneous mixture. So homogeneous means it only looks like one thing. So the particles are distributed evenly. So when you mix lemonade, after you put the powder in and you mix it up, now it's a solution and it's just one color. You don't see the powder anymore. You don't see the water exactly. It's just all mixed. Heterogeneous is, for example, like cereal and milk. Cereal goes into the milk, but it doesn't mix together. You can still see it. You see two clear different substances. So the heterogeneous mixture, you're going to have more than one particle or substance that you can see. So number 3, write it down. And number 3 is going to be a homogeneous mixture. And that once they're mixed together, that is a solution. Okay, solutions are composed of two things. We have the solute and the solvent go together to make the solution. So number 4, you're going to write down solutes and solvents. Okay, now depending on how much powder you put into the water, either chocolate milk, lemonade is a common one, sugar, salt. Now, if you put a little bit in there, then the water is still unsaturated. So you can put a certain amount of powder, solutes, into the solvent, and then you can mix it up. But if you put too much powder in there, not all of it's going to mix up. But all right, a solution that contains all of the solute that it can possibly hold. So where the water is full, but it's not oversaturated, that's going to be a saturated solution. So number 5, it's going to be saturated. Okay, number 6, when one of the parts of the solution is water, that's what we call an aqueous solution. So the solutions that we're dealing with for this unit, aqua meaning liquid, and then water. So liquid water is going to be an aqueous solution. Okay, number 6 is aqueous, Aqueous. All right, if we're making Kool-Aid, sugar, Kool-Aid powder, and water, which part is going to be the solvent? Okay, solute is the powder and the sugar, and then solvent is going to be the water. It's what we mix it into. Okay, now Michael's science experiment is salt in water. The salt would be considered the solute. The powder that goes into it is going to be the solute. All right, you can make a solution more concentrated. If you want it more concentrated, you want a lemonade mix to be stronger, then you need to put more solute in it. You need to put more powder. So once you put more of it in there, then it's going to be more concentrated. Okay, number 10, Avery's conducting a science experiment. When water is added to a solution, it is called diluting it. So if you add more water to a mixture and you add more water to a solution, then there's less concentration. Less concentration means that there's more dilution. So more water will make it more diluted, or it's called dilution. Okay, Luna and Daniel are conducting an experiment to see how much they can dissolve into a solvent. Well, we put solutes into a solvent. The solute can be salt, sugar, powder, any type of mixture that we put into any type of solvent that we can put into water to any type of solute we can put into the water. Okay, number 12, a solution that contains all of the solute that can hold at any given temperature. If all the solute that it can hold, then that means the water is saturated. And it's fully saturated. It's not undersaturated and it's not oversaturated where there's too much powder in there. Okay, looking at this one, all right, Aria is making lemonade. She adds sugar. What do we call the sugar when we put it in? The sugar is going to be called the solute. It's the powder or the granules that we put into water. Okay, a solution is a kind of what? It's a type of mixture. So it's a mixture that blends together and it just becomes, it looks like an evenly distributed, just one soluble mix, a solution. All right, sweet tea. What do we call sweet tea? Sweet tea is the solution. It's what you get after you mix a solute and a solvent. Number 16, sugar. Is sugar going to be the solvent or the solute? All right, sugar is going to be the solute. Okay. Is Kool-Aid mix, Kool-Aid, the powder, is that going to be a solute or a solvent? The powder is going to be a solute. What about water? Is water going to be the solvent or the solute? Water is what we mix stuff with, and that is going to be the solvent. What happens to the concentration of a solution when more solvent is added? If you add more water, the concentration goes down. It becomes more diluted, but the concentration decreases. Okay, which factor does not affect the rate of dissolution? Temperature. If you warm up water, you can absorb. You can put more solute into it. It increases the solvent capability of the liquid. If you have more surface area, it can dissolve faster. Agitation is stirring. If you stir it up, it can dissolve faster, the rate of dissolution. Color, whether it's blue, green, purple, or red, the color does not matter how fast something is stirred up or dissolved. So number 20, color of the solute doesn't matter. All right, if you increase the temperature of a solution, what happens to the rate of dissolution? So the rate of dissolution, how fast it mixes, if it's warmer, it's going to mix easier. It increases. How does increasing the surface area of a solute affect the rate of dissolution? The rate of dissolution is how fast it can mix together, how easily it can mix. All right, if you have more surface area, it's going to increase the rate. And the last question, what is the effect of stirring, agitating the water? If you move the water around, you stir it, agitate it, it's going to increase the rate of dissolution. It's going to make it easier to mix together. Okay. All right. So make sure your name is on top of the sheet of paper and that you've answered each one of the vocab questions. And you're going to turn that paper in for right now, but we're going to use it in class as we're working on quizzes and practicing our aqueous solution vocabulary.